This is Deirdre Blake for Dr. Dobbs TV, welcoming you to a 10-minute tutorial on first-class functions and lambdas in Java 8, presented by the authors of Java 8 in Action.
First-class functions in Java, presented by Manning Publications, with Raul Gabriel Irma, Mario Fusco, and Alan Mycroft. You may be hearing a lot of buzz about Java 8 and functional programming. In this first video, you'll see how to write more flexible code by regarding methods as first-class values and using lambda expressions to concisely represent behaviors. Let's start by looking at the idea of functions as first-class values. First, we'll consider all the possible values you can manipulate in a Java program. The simplest are primitive values, such as the numbers 42 of type int or 3.14 of type double. Objects are instances of a class. Examples of objects as values include ABC of type string, new integer 24 of type integer, and explicitly calling a constructor for a class, here shown as class C with the parameters 7 and xyz. Even arrays are objects. So what's the problem? There are various other concepts in Java that we consider to be second-class Java citizens because they're not values. Methods and classes are prime examples of these second-class citizens. Methods are fine when defined inside classes, which in turn may be instantiated to produce values. However, neither are values, which can constrain your thinking and make it harder to program. In other languages, like Scala, regarding methods as first-class values makes programming easier by adding to the toolset available to a programmer. Methods as first-class citizens. Programs embracing the idea of methods as values are said to be functional-style programs, which essentially just means programs that pass functions around as first-class values. The designers of Java 8 decided to allow methods to be values. The first new Java 8 feature we introduce is called method references. Here's how it works. Suppose you want to filter all the hidden files in a directory. You need to write a method that, given a file, will tell you whether it is hidden or not. We'll use a method inside the file class called isHidden. Think of this as a function that takes a file and returns a Boolean. In Java 8, you can rewrite the code this way. Notice we use isHidden as a value by writing file : isHidden. Cool. We already have the function isHidden available, so we can just pass it to the listFiles method. No longer are methods second-class values. In addition to allowing named methods to be first-class values, Java 8 allows a richer idea of functions. One of the most significant additions is lambdas, or anonymous functions. Let's take a look at a lambda expression. For example, you can write int x arrow x plus 1 to mean the function that, when called with argument x, returns the value x plus 1. You may be wondering, how does this help me write programs? Well, let's step through an example to see. Suppose you have a farm inventory application with a class apple, declaring a method getColor, and an inventory that's a list of all apple objects. It's reasonable to think that you might want to select all the green apples and return them in a list. You'd typically call the code to select just the green apples a filter. In this case, you'd write your filter as a method called something like filter green apples. Let's look at an example of what this method might look like. Notice here, result is a list, which accumulates the result. It starts as empty, and then green apples are added, one by one. Here, the highlighted code instructs our method to select only green apples. This works perfectly, assuming all you'll ever need this filter to do is to select green apples. Now suppose you'd also like to compile a list of apples that weigh over 150 grams. Time for another filter, which you might even create by copying and pasting the green apple filter. As you can see, apart from a few minor modifications, this new heavy apple filter is essentially the same as the green apple filter. In fact, apart from the method's name, the highlighted line is the only significant change. We all know the dangers of copy and paste for the software engineer. And hey, these two methods vary only in one line, the highlighted condition inside the if construct. Here's where passing a method as a value is really handy. Java 8 makes it possible to pass the code of the whole condition as an argument, thus avoiding the code duplication of the filter method. Let's look at how you can write this and step through some of the important features of this code. Check out this line. We've included this for clarity. Normally, it's simply imported from Java util function. The method filterApples takes a predicate as a parameter p. The purpose of this line is to check if the apple matches the condition represented by p. And to use this, you simply call filterApples with parameter inventory and a method reference to either isGreenApple or isHeavyApple. The key idea to take away for now is that you can pass a method around in Java 8. Introducing Java 8 lambdas, a new notation for anonymous functions. While passing code is a way to give new behaviors as an argument to a method, it's currently quite verbose in Java. Lambdas, also known as anonymous functions, help eliminate the verbosity of declaring and instancing an anonymous inner class. In our previous apple sorting example, we showed you that passing methods is useful. We also reminded you that it's really annoying to write separate definitions for the methods isHeavyApple, isGreenApple, and any other required condition, especially when they're likely to be used only once or twice. Fortunately, Java 8 has solved this too. Enter the lambda expression. The new lambda notation lets you represent your method differently. Lambda expressions follow a straightforward syntax, shown here. Now let's look at a few specific examples based on our earlier farm inventory code. As you can see, using this new approach, you don't need to write a method definition that's used only once. The code is crisper and clearer because you don't need to search to find the code you're passing. A lambda expression can be understood as a kind of anonymous function that can be passed around. It doesn't have a name, but it has a list of parameters, a body, a return type, and also possibly a list of exceptions that can be thrown. Lambdas fix the verbosity problem because they let you pass code in a concise way. Thus, you can cope with changing requirements by using a behavior represented by a lambda as a parameter to a method. Let's take a closer look. We define a lambda expression as a concise function without an explicit name that can be passed as an argument to another function or method. That's one big definition. Let's break it down. Every lambda expression is composed of three parts: parameters, an arrow, and a body. In this case, the body of the lambda compares two apples using their weights. This expression has two parameters of type, apple, and returns an int, the comparison of the weight of the two apples. Now let's parse the definition a little more. A lambda is a function because it isn't associated with a particular class like a method is. Like a method, a lambda has a list of parameters, a body, a return type, and a list of possible exceptions that can be thrown. A lambda can be called an anonymous function because it doesn't have an explicit name like a method would normally have. This means less to write and think about. We say a lambda can be passed around because it can be passed as argument to a method. A lambda is concise because you don't need to write a lot of boilerplate like you do for anonymous classes. A lambda includes a list of parameters. For instance, in our example, The lambda mirrors the parameters of the compare method of a comparator, 2 apples. Finally, a lambda uses an arrow. This is simply the syntactic convention, represented by a dash and a greater than sign, used to separate the list of parameters from the body of the lambda. Once you get used to them, you'll find lambdas to be pretty powerful. The Java 8 designers could almost have stopped here, and perhaps they would have if they didn't have to consider programming for multi-core CPUs. There are additional enhancements that are particularly useful in a multi-core environment. To best exploit parallelism, Java 8 adds a whole new collection-like API called streams, containing a comprehensive set of operations similar to filter that functional programmers may be familiar with. For example, map and reduce, along with methods to convert between collections and streams. Well, turns out many of these operations can be parameterized with lambda expressions. In our next video, we'll explore how the Streams API allows and encourages the elements within a stream to be processed in parallel. For a deeper look at Java 8 lambdas, pick up Java 8 in Action, Lambdas, Streams, and Functional Style Programming. You'll find it at manning.com/IRMA. Save 38% on Java 8 in Action, Lambdas, Streams, and Functional Style Programming, and any other Manning books. Just enter the coupon code in the promotional code box when you check out. This discount applies to your entire purchase, ebook, pbook, or MEEP. Only at manning.com. First Class Functions in Java, presented by Manning Publications, with Raul Gabriel Irma, Mario Fusco, Alan Mycroft, and Lambda Man.